Okay, so today we will start with dynamics. Dynamics is the part of mechanics that deals with the big question of why is the object moving this way? Remember what we said in kinematics? In kinematics, we said that the object, the biggest question in kinematics was how is the object moving? And when we talked about this, we said that the object is moving in a uniform motion or non-uniform motion. And in order to fully describe the motion, what we were doing is we were saying and defining what is the distance, what is the displacement, what is the velocity, what is speed, what is acceleration, and what is time. So those were the quantities that we were talking and discussing in kinematics. But in dynamics, we are asking why is the object moving in a uniform motion? What is making this particular object to move in a non-uniform motion? What is, why is it? What is the mass of the object? So this is dealing with that as the big question in the unit. Those two parts, kinematics and dynamics, are part of mechanics. And very often when you go to university, you will see that those are treated together as one unit, and they are called mechanics. And the father of physics, as we know, is Newton. And then this is what we will talk today and for a long period of time. We will talk about the laws of Newton's for the motion. Anyway, so the biggest question that we will discuss today is what is force? You have heard this, the concept of force, the word of force, but we will discuss today as what is force. It doesn't want to bring that, but what is force? Now, I want you to tell me on the chat, what is your concept of force? It doesn't matter what are the, if the question or if the answer is right or not, but I want to know, what do you think that force is? Okay, so the answers on the chat were like, force is something that it needed to be, the object to be experiencing, so that is moving, or something that acts on an object to change its shape or velocity. This is a very good one. Then the quantity needed to cause a movement, the quantity needed, there is always an equal and opposite force. Yeah, and all those answers here are very, very good. And in physics, what do we see as the force is anything that is pushed or pulled. So push or pull. When we push an object with a given mass, then what we are doing is we may move that object, or we may need to exert a bigger force to make this object move. So anything that we see that is pushing or is pulling, it doesn't matter in what direction is it going, then this is, we say that this object is experiencing a force. And it is very important that the force is acting on an object. I think that it should be in an object. but it's fine. So is acting, no, on an object. So if we do not have an object, it doesn't matter what is the force, we will not see any effect of that force. In order to see the effect that the force has, this force need to be experienced, need to be exerted on an object. You cannot have a force that is out of nowhere and you don't have an object there, which means that you will have an object that has a shape and a mass. Okay, an object without a shape and a mass, it's not an object. A thing without a shape and a mass is not an object. Okay, so now another very important thing about the qualities or the what force possesses is that force is a vector. And what did we say about vector on the first part of physics? That is very good. That means that we have a magnitude and direction. Those are very good answers. And direction. And the magnitude, we have said always, is that is the numerical value along with units. And since we are here, so this is numerical value and units. And since we are at units, let's talk a bit about the units here. The units for the force are newtons. So units are newtons, which actually are equal, or the 1 Newton is equal to 1 kilogram meters per second squared. In a lot of textbooks, what do you see is meters seconds to the power of -2. It's something like this, but even both of them are the same. So when we are saying Newton, what do we mean is that is kilogram meters per second squared. Okay, we have Newton now is considered to be as part of the International System Unit, SI unit, and it is to honor the work that Newton have done in physics, but actually is, if we go to the basics of the International System Unit, is kilograms times meters per second squared. Okay. Another quantity that force possesses is that it can be experienced when we are in contact or at a distance. What do I mean by this? So if we have an object sitting on the table, and what we are doing is we are pushing that object to a certain direction, then we need to be in contact with this object to have that, to see the motion of the object, to actually exert the force on that object. But when we are dropping an object, from a certain height, the force of gravity, which is the universal force, is a force that is experienced by the object, even that this object is not in direct contact with the object. Okay, so force is the conduct. It's when we have we need to have a contact with the object, and at a distance, usually it is when we have a field that is surrounded by the object. And you will see on physics 20, you will see force of gravity as having the field, or the gravity field. Any object with a mass has a gravity field. And when you go to physics 30, you will see the electric field and the magnetic field. So even though that they are at a distance, still you can see and experience, the objects can see and experience the forces between the objects. Okay, now let's take a look at what forces are we discussing on physics 20. Okay, what are the forces? Forces in general in nature, but with the focus of the physics in nature. So the very first force that we will talk is that is known as the force of gravity. Okay, force of gravity. In contact or at a distance, force of gravity is a force that is experienced at a distance. So you are experiencing force of gravity no matter where you are standing. You are standing at the surface of the earth or at highest building in Calgary, you still are experiencing force of gravity. Force of gravity is calculated. First of all, it's assigned as Fg. And it is calculated, the magnitude of it is calculated as mass times acceleration due to gravity. The direction is always toward the center of the earth. The center of the earth, or if you are in another planet, the center of the other planet, the center of the object. What is characteristic of force of gravity? Stop existing beyond the surface of the earth. So inside the earth, you do not experience force of gravity. I will say stop existing inside the earth. Inside the earth, you will see a different force which you may talk later on in your life. So it stops at the surface of the earth. Okay? Questions? The second force that we will see is that is known as the tension force. Tension, when you have an object that is hanged with a string, then the string is carrying that is known as the tension force. So when we replace the string with a force, because we don't always have the picture there, but when we replace the string with a force to build that is known as the free body diagram in dynamics, what do is we draw the force that starts at the object and goes along the string. So we'll see some situations here. Let's suppose that we have an object with a given mass that is hanged with a string that goes like this, and here is the wall. Okay, when we replace or when we draw the tension here, the force of tension starts at the object, so starts at the object, and then goes along the string. Okay, this is called as the tension. I have the tendency to say T, but you can even say force of tension. Both of them are right. I have the tendency to say just T for tension. However, if you have something like this, an object is here, and you'll have two strings that are the object is tied with, and then you will have two tensions, one that goes like this, and the other one that goes like this. Starts from the object and goes along the string. Starts from the object and goes along the string. Or if you have a different situation, suppose that you have an object that is like this in the wall. Those are the two strings. Then the force of tension starts from the object and goes along the string. Force of tension starts from the object and goes along the string. Is it clear? The third type of force that we will discuss and talk in dynamics a lot is that is known as the normal force. Normal force exists only when we have an object that is on a surface. So the way that I assign normal force is like this, but sometimes it is just N for normal. I have the tendency to go normal force like this. It's an old habit. And it is a force that exists only when you are in contact with the object. The direction of the normal force, magnitude varies, the direction of the normal force is always perpendicular to the surface. Direction is perpendicular to the surface. So if we have a situation like this, you have a horizontal surface and you have an object with a given mass, then force normal will be perpendicular to the surface. And perpendicular means 90 degrees, guys. So this is force normal. However, if you have an incline and you have an object here, then force normal will be perpendicular to the surface. If you have an incline that goes in the other direction, then and the object is here, force normal is perpendicular to the surface. The magnitude of both of them, tension and force normal, changes. It depends on the situation that you are at. But as the direction for force, tension force, what we have is starts from the object, goes along the string, and for force normal is perpendicular to the surface. Perpendicular means 90 degrees. Is it clear? A force that we will use in physics 20, but not quite now, a bit later on, is that is known as the force of spring. And when you have an object, let's suppose that you have an object here that is with a spring, and you are pushing it or or not. This is a force applied. Then what is happening for the spring itself is exerting a force. The force of spring is always, force of spring is assigned with Fs, first of all. And it is always the opposite of what you are doing. If you are compressing, the spring has the tendency to expand it. If you are expanding, the spring has the tendency to compress it. So it is always opposing what you are doing to the spring. And it is calculated as negative K, where K is the coefficient of the spring. And as I said, we will talk later on about this a lot. Negative K, X as a vector, where X is either the expansion or the compression of the spring. So it is always the opposite of what you are doing to the spring. If you are expanding it, then the spring will have the tendency to compress it. If you are compressing it, the spring will have the tendency to expand it. And you probably have experience of this. If you have a spring and you are compressing it, then you will feel a force in your fingers because the spring wants to expand it. But if you are expanding it, then you will experience a force that will have the tendency to compress the spring. Have you ever experienced this in your life? A very, very important force in our life is that is known as the force of friction. Force of friction, even though that in the world of engineering, what they are doing is to have the most efficiency possible by eliminating the force of friction that exists between the parts when they are designing something. Force of friction is a very, very important. Without force of friction, believe it or not, we will not be able to move, to walk, because it's the force of friction that exists between our feet and the surface of the earth that make it possible to walk. Have you ever experienced walking in the ice? It's a very difficult. Why? Because force of friction is very small. Therefore, you cannot walk easily in the ice. However, in a gravel road, then yes, you can. So force of friction, first of all, is assigned as this force of friction with subscript friction. And the direction of it, magnitude changes, the direction of it is always against the motion. Against the motion. So what does that mean is that if you are moving east, then force of friction will be west. If you are moving north, then force of friction will be south. And if you have a situation like this, that you have an object that is moving in this direction, then force of friction will be in the opposite direction. It is important to emphasize that force of friction exists when you are in contact with a surface. So in the cases when we had the object that is hanged with two strings, we do not have a force of friction even if the object is moving. We don't have a force of friction because there is no contact between the two surfaces of the object and the surface that you are moving. But if you have a situation like this, when you have an incline and the object is on the top of incline and it is moving on this direction, direction of motion. Then force of friction is the opposite of it, force of friction. The magnitude of force of friction. So if you are dropping an object, then force of gravity is dragging the object down, is going toward the center of the earth. And then the second force that actually in reality the object will experience will be force of friction of the air, or resistance of the air. You even have noticed when I was giving some kinematics equations saying that suppose that the air resistance doesn't exist, neglecting the air resistance and things like that, or things along those lines. Actually, force of friction of the air exists, even though that we don't feel it, we don't see it, because we are not living in a vacuum. But there are experiments that are done and proven that the force of resistance of the air exists. And if you have an object, so if you have an object that is dropped in a vacuum, an object with mass, a given mass, doesn't matter what is the mass, and then here you have a feather, and I don't know how to draw a feather, but I will just do this. This is a feather. And you are in a chamber that is a vacuum. Then they will reach the bottom of the chamber at the same time. Why? Because the gravity that they are, if you drop them, the gravity that they are experiencing is the same for both of them, and for the object with a mass and solid, you will, and for the feather, since it is a vacuum, you will not experience any force of resistance of the air. However, if you are doing this experiment in a chamber that there is air, the same experiment, and you are doing it, the same objects and the same feather, then what you will see, the object will reach the bottom before the feather, because the feather will experience a way higher air resistance than the other object. So air resistance exists, even though that we do not fully experience, because what we haven't seen our life in vacuum. This is the best way to say it. And the last thing that we will talk in terms of the forces is when we have a force that is pushing or pulling, doesn't matter what it is. We call it force applied. Usually force applied are dragging an object or they are pulling an object, okay? They are pushing or they are pulling. Force applied, we assign them as FA for applied, and every force that we saw on this part of the lesson, everything that we talked, they are all forces, and the units for it are newtons, kilograms, meters per second squared. So the direction of the force applied and the magnitude of force applied will vary based on the situation that we are at or what the problem is giving us. So if we have an object that is at a surface and we are pushing it with a force applied that is parallel to the horizontal, we will say it is, let's suppose, 20 newtons. And then based on this, we will draw the free body diagram. Based on the situation that we are at, we will draw the free body diagram. Is this, or if we have an object that is like this, then the object will have the tendency to go down because it is on the incline. However, what we are doing is we are applying a force applied here. That is, let's suppose 15 newtons to keep the object stationary, not moving. Okay, so force applied can be even with an angle, with a horizontal. So if we have a horizontal surface and an object that is on the horizontal surface, then you can exert a force that goes like this with a certain angle with the horizontal. And then you can say that the force is, let's suppose, 15 newtons, and the angle is whatever is the angle, in this case 30 degrees. So the magnitude and the direction of the force applied will be a force that is given to your situation.